In this power series video, we're going to take a look at how to find the radius and the interval of convergence. So we have the series from n is equal to 1 to infinity of negative 1 to the n, x to the n, all divided by n. So for this, we want to first do the ratio test. So we're going to have the limit as n approaches infinity of a to the n plus 1, so we're going to have negative 1 to the n plus 1, x to the n plus 1, divided by n plus 1, all divided by a sub n, which is negative 1 to the n, x to the n, divided by n. And now I'm going to rewrite this division as a multiplication, and I'm going to rewrite some of my factors. So I have the limit as n approaches infinity, and then I'm going to have negative 1 to the n plus 1 I can rewrite as negative 1 times negative 1 to the n, and x to the n plus 1 I can rewrite as x times x to the n, all divided by n plus 1, times, and now we're going to invert the denominator, so I have n divided by negative 1 to the n, x to the n, and now I'm going to cancel the factors that I can, so I have negative 1 to the n cancels, x to the n cancels, and then our absolute value are going to make this negative 1 positive 1, so I'm going to be left with the limit as n goes to infinity of n over n plus 1 times the absolute value of x, and this is equal to the absolute value of x. And then we have to remember that in order for the ratio test to be convergent, it has to be less than 1. So we can see that our radius of convergence is 1. And then in order to determine the interval of convergence, we need to plug 1 and negative 1 into the series for x and figure out if it's convergent or divergent. So we're going to have, when x is equal to 1, we have the series from n is equal to 1 to infinity of negative 1 to the n, 1 to the n, all divided by n. So here we have the alternating series test. So we need to do the limit as n approaches infinity of b sub n, which is 1 over n, and this limit is 0. So since our limit is 0, now we need to do is make sure that b of n plus 1 is less than b of n. And as our denominator continues to get bigger, our overall number is going to continue to get smaller. And if you wanted to prove it, we could say that f of x is equal to 1 over x. F prime of x is equal to negative 1 over x squared. And since the first derivative is always decreasing, then we know that all of the b n plus 1's are going to be less than the b sub n's. So this series here at 1 is convergent by the alternating series test. And I'm going to say AST. And now we need to do the same thing at negative 1. So we have x is equal to negative 1. And when we write the series from n is equal to 1 to infinity of negative 1 to the n times negative 1 to the n over n, and we could rewrite this as 1 over n, because we have negative 1 to the n and negative 1 to the n. So whenever n is going to create negative 1 to be positive, then they're both going to be positive. And whenever they're negative, we're going to have negative 1 times negative 1. So either which way, we're going to have 1 in the numerator. And we know that the series of 1 over n is divergent by harmonic series. So we need to include 1 and not include -1 in our interval. So our interval of convergence is going to be -1 is less than x is less than or equal to +1. And in this next example, we have the series from n is equal to 1 to infinity of x minus 3 to the n minus 1 divided by 3 to the n minus 1. And I'm going to rewrite this so it looks like the geometric series. So I have n is equal to 1 to infinity of x minus 3 over 3 to the n minus 1. When looking at a geometric series, we know that our r value, which is x minus 3 over 3, the absolute value of r needs to be less than 1. So the absolute value of x minus 3 divided by 3 needs to be less than 1. And then we can have an inequality from -1 is less than x minus 3 divided by 3 is less than 1. And now multiply everything by 3. So we have -3 is less than x minus 3 is less than 3. And now add 3. So we have 0 is less than x is less than 6. So our radius of convergence, or capital R, is equal to 3. And our interval of convergence is 0 is less than x is less than 6. And that's our video on power series.